Welcome, students. Have you ever wondered why hydrogen, the simplest element in the universe, seems to have two personalities? Let's take a closer look. Hydrogen, with just one proton and one electron, holds the distinction of being the first element in the periodic table. But here's the twist, it's placed in group 1, right above lithium, among the alkali metals. However, hydrogen doesn't always play by these alkali rules. In fact, its behavior is more like that of halogens in group 17, especially when it reacts. It can either lose its single electron, becoming H, or gain one to become H, making it a versatile player in the world of chemistry. This dual behavior has puzzled chemists for years, and there's still no consensus on which group hydrogen truly belongs to. As we move forward, we'll dive into this fascinating debate. Now, let's break down hydrogen's atomic characteristics. With an atomic number of 1 and a mass number close to 1, hydrogen's electronic configuration is simple 1s superscript 1. Its valency is also 1, meaning it can either donate or accept one electron, making it highly reactive. But hydrogen isn't a lone ranger, it has isotopes. Prosium, the most common, has just a single proton, while deuterium and tritium have 1 and 2 neutrons, respectively. But what makes hydrogen truly interesting is its ionization enthalpy, which stands at 1312 kJ-mol. This is surprisingly high for an alkali metal, bringing it closer in energy to the halogens like fluorine. This fact might make you wonder, is hydrogen more like an alkali metal or a halogen? We'll explore that next. Now, the fun part, hydrogen's dual nature. On one hand, hydrogen behaves like an alkali metal. It can lose its lone electron, just like lithium, sodium, or potassium, forming H. But wait, hydrogen can also act like a halogen. When it gains an electron, it becomes H, much like halogens such as chlorine and bromine. This gives hydrogen the ability to form ionic hydrides like Na and CaH, which resemble the compounds formed by alkali metals. On the other hand, it forms covalent compounds like HCl and HO, which are similar to the halogens. So, hydrogen bridges the gap between the S block and P block elements, making it a fascinating element to study. So, where does hydrogen truly belong in the periodic table? Its placement above lithium in group 1 makes sense considering its 1s superscript 1 configuration. But its tendency to form H, like the halogens, has led some scientists to place it in group 17. Some even suggest placing it separately at the top, acknowledging its unique properties. Modern periodic tables take the middle ground, recognizing hydrogen as a special case that doesn't quite fit into any one group. And this is why hydrogen remains so versatile, forming a variety of compounds and playing critical roles in chemistry, from acid-base reactions to redox processes. Let's put hydrogen's dual nature to the test with an example. Compare the ion formation of hydrogen, lithium, and fluorine. When hydrogen loses an electron, it becomes H, just like lithium, which forms Li. On the other hand, fluorine gains an electron to form F, just like hydrogen can. From this, we observe that H behaves like an alkali metal cation and H like a halide anion. This experiment shows us that hydrogen is truly a bridge between group 1 and group 17, embodying traits of both alkali metals and halogens. A little tip for your exams: when you're asked about hydrogen's position, always write both the H and H pathways to show its dual nature. To wrap it up, hydrogen's position in the periodic table is still a topic of debate. It shows characteristics of both alkali metals and halogens, yet it doesn't completely fit into either category. As a result, we treat hydrogen as a unique class of its own. Its simple atomic structure and ability to form both ionic and covalent bonds explain why it's found in a variety of chemical reactions, from acid base chemistry to redox and even organic and nuclear chemistry. So, next time you encounter hydrogen in a reaction, remember its dual personality, a truly remarkable element that defies classification.